Dear chemistry aspirants, right now I have the heterogeneous equilibria, and this subtopic will come equilibrium of chemistry. And equilibrium in a system in having more than one phase is called heterogeneous equilibrium. The equilibrium between water vapor and liquid water in closed container is an example of heterogeneous equilibrium. H2O and H2O H2O gas. In this example, there is a gas phase and a liquid L for liquid, and in the same way, equilibrium between a solid and its saturated solution CaOH2 as solid and aqueous calcium aqueous plus 2OH minus aqueous is a heterogeneous equilibrium. Heterogeneous equilibrium often involves pure solid or liquids. We can simplify equilibrium expressions for the heterogeneous equilibria involving a pure liquid or a pure solid as the molar concentration of a pure solid and liquid is constant, i.e. independent of the amount present. In other words, the substance X is involved, then X as and X liquid are constant, whatever the amount X is taken. Contrary to this, X, Z gas and aqueous will vary as the amount of X is given, volume varies. Let us take thermal dissociation of calcium carbonate, which is interesting and important example of heterogeneous chemical equilibrium. CaCO3 solid and CO as solid plus CO2 gas 7.16 on the basis of stoichiometric equation. We can write Kc is equal to CaOS and CO2 gas by CaCO3 solid, since CaCO solid and CaO solid are both constant. Therefore, modified equilibrium constant for the thermal decompositions of the calcium carbonate will be Kc is equal to CO2G solid gas G for gas. Kp is equal to PCO2. And units of equilibrium constant is the value of equilibrium constant Kc can be calculated by the substituting the concentration terms on mole per liter, and Kp partial pressure is substituted in Pa, Kpa bar or atm. This results in unit of equilibrium constant based on molarity or pressure, unless the exponents of both the numerator and denominator are same for the reactions. H2G it means gas, and I2 gas is equal to 2HI. Kc and Kp have no limit unit. N2O4G, and you will see here 2NO equilibrium G. Kc has unit mole per liter and Kp has unit bar. Equilibrium constant can also be expressed as dimensionless quantities if the standard state of reactants and products are specified for a pure gas. The standard gas state is the L bar, therefore is a pressure of 4 bar in a standard state can be expressed as 4 bar per 1 bar is equal to 4, which is a dimensionless number. Standard state CO for a solute is 1 molar solutions, and all concentrations can be measured with respect to it. The numerical value of the equilibrium constant depends on the standard state chosen. Thus, in this system, both Kp and Kc are dimensionless quantities but have different numerical value due to different standard states. Now come to the point here. This shows the particular temperature. There is a constant concentration pressure of CO2 equilibrium with CO as solid in CaCO3 solid. Experimentally, it has been found in the 11K. The pressure of CO2 in equilibrium with CaCO3 as solid and CO as solid is 2.0 into 10 to the power 5 Pa. Therefore, equilibrium constant as 1100 K for the above reactions is Kp PCO2 is equal to 2 into 10 to the power 5 Pa oblique 10 to the power 5 Pa is equal to 2. Similarly, in the equilibrium between the nickel carbon monoxide and nickel carbonyl used in the purification of nickel Ni as solid and 4COG gas, equilibrium NiCO4G in equilibrium constant is written as Kc NiCO4 by CO4. It must be remembered that for the existence of the heterogeneous equilibrium, pure solids or liquid must also be present, however small or amount of maybe small, the amount may be at equilibrium, but their concentrations or partial pressures do not appear in the expression of the equilibrium constant. In the reactions Ag2OS, solid, 2HNO, 3 aqueous, and you can see the reactions is 2AgNO, 3 aqueous, and H2O liquid. KCAgNO3 all square by HNO3 all square. So here is the problem. You will see here some problem, the value of K for the reaction, and here the other solutions here. And next video we will discuss application of equilibrium constants. We will meet in the next session. Till then, thank you very much.